Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are studying quadratic relations. It's a video in which we take up questions, word problems rather, that are based on quadratic relations but where no equation is given to you. In other words, you're going to have to create the equation based on the information given. So from a worksheet that I've given out, this is question number 2. And the question says, the sum of the squares of 3 consecutive integers is 77. Find the integers. Okay, pretty straightforward question. Certainly if we weren't grade 10 quadratic relation students, you might even be able to just guess and check fairly quickly. But that's not going to give us any marks because, well, the whole question is designed to make sure you understand how to do proper word problems and how to set up a quadratic and then, of course, how to solve it. So proper word problem means we need to start by defining a variable. So all we're looking at here, what we're looking for are 3 consecutive integers. So remember, consecutive integers are 3 whole numbers, meaning no fractions or decimals, in a row. So those are 3 consecutive integers. Those are 3 consecutive integers. And those are 3 consecutive integers. So you get the idea, 3 consecutive integers. But the problem is I don't know which 3. So what we're going to do is we're going to do what we always do in consecutive integer questions. We're going to define x to be the first, or if you want, the smallest. So for example, 6, 7, 8, I'll put that one back on. I'll put 11, 12, 13 back on. So now we're going to start with x. So how do I get the next integer? Well, when I started at 6, I added 1. When I started at 11, I added 1. So the next integer will be x plus 1. And what would this next integer be? So you could say x plus 1 plus 1. So we take this number and add 1. But, I mean, who says x plus 1 plus 1? People who haven't learned how to collect like terms. It's just x plus 2. So 3 consecutive integers will always look like this. The first one's x, then x plus 1, then x plus 2, because that way there are 3 numbers all in a row. So we're going to let x be the smallest integer, and we're not going to define what y is. We're only going to stick to one variable in this case. And we're going to say, therefore, the other numbers, or the other integers, are x plus 1 and x plus 2. Boom. So now we have our 3 consecutive integers defined. Now let's see what we're supposed to do with them. The sum, that means add, of the squares of 3 consecutive integers. So the sum of the squares. Well, let's talk about what the squares are. So the squares of consecutive integers, there's the first one squared. Here's the second one squared. Oops. And here's the third one squared. So here are the squares of 3 consecutive integers. So you see how we're kind of rebuilding this sentence mathematically. We now have the squares of 3 consecutive integers. And what we really wanted was the sum of the squares. So the sum of the squares of 3 consecutive integers is, or equals, 77. So in this case, we don't have 2 variables. We don't have 2 equations. We have 1 variable, and that led us to 1 equation. We just had to carefully work out what that equation was. And again, once I've written this equation, all I'm concentrating on now is doing the math, solving properly, and getting answers. And then we'll go back and look, if we've answered fully or not. So let's go ahead and, collect like terms, etc. So I've got x squared here, x plus 1 squared. So you're welcome to do this, right? Because we know that when you square something, it means multiply twice. And then you can do FOIL on it and so on and so on. But if you're one of my students, you know that I prefer this method, which is where we square the first, double the product. The product would be 1x, double that is 2x, and then square the last. 1 squared is 1. So here's the first squared, the second squared. So again, I'm going to do square the first, double the product. The product is 2x, If you double 2x, you get 4x. And then squaring the last, 2 squared is 4. So again, you can see that I still kind of have the shape of first, second, and third, but now I'm going to lose the shape, the 1, 2, 3, because I'm going to collect like terms. So I have 1, 2, 3. I have 3 of these things called x squareds. Ooh, fancy colors. Let's go with this one. I have 2x plus 4x. So that gives me plus 6x. Then I have, let's use another fancy color here. Ooh, let's do this one. So now I have plus 1 plus 4. So that's going to give me plus 5. And over here, I still have 77. So now I'm going to subtract 77 so that it equals 0. Remember, it always has to equal 0 to solve a quadratic. So 5 subtract 77 is negative 72. So there's my quadratic equation. It equals 0. And now I can solve using whatever method I'm comfortable with. Let's try factoring. And I'm factoring because I know I'm supposed to get an integer answer, and factoring usually leads to integers. So let's go ahead and see what happens. So first, I'm common factoring out that 3. 72 divided by 3 is 24. And then what I'm left with is a nice looking simple trinomial. So are there two numbers that multiply to negative 24 and add to 2? Yes, there are. Positive 6 and negative 4. So again, they add to negative 2 and they multiply to negative 24. So now that I've factored, I can go ahead and solve for x. So I have 3 things multiplied together. If any one of these 3 things was 0, I would have an answer to this. I would have solved this equation. Now it's impossible to make 3 equal 0 because 3 is 3, so nothing from here. However, the next bracket says that x plus 6 could equal 0. And if x plus 6 was equal to 0, I don't care what I have here or here, the whole thing is 0. And that means that x equals negative 6 would make this expression 0. Same idea now if I go to this third bracket in yellow. If this bracket was 0, I don't care what this says or this, because if this is 0, 0 times anything is 0. So x minus 4 equals 0, so that means x equals 4 is a possible solution. Those are the exact same answers you would get if you had used the quadratic the quadratic formula. I just decided not to. So I get 2 possible answers. Now, don't write inadmissible. Remember, this is a question about integers, not width or length or whatever. Integers are allowed to be negative. Let's just make sure, let's check and see which or both or none of our solutions actually works. So if x is negative 6, then my other numbers are, add 1, there's my 3 numbers. Now, let's see. Do these 3 numbers have the property that the sum of the squares adds to 77? So let's check. So is it true that the sum of negative 6 squared plus negative 5 squared plus negative 4 squared, does that equal 77? So 36 plus 25 plus 16 is indeed 77. So here's one set of correct answers. So one answer is that the consecutive integers negative 6, negative 5, negative 4 is a valid solution to the system. So let's check the other value of x we calculated, which was 4. And if we calculate 4, then the next consecutive integer is 5, and then 6. So again, do these 3 numbers have the property that if I square them and sum those squares, I get 77? Well, obviously we know that's true because when we squared negative 6, it's the same thing as squaring positive 6. So yes, both sets of numbers are valid solutions. So in our conclusion, we have to reference both. Therefore, the numbers are negative 6, negative 5, negative 4, or 4, 5, 6. So there's 2 solutions, this set or this set. I hope that was useful. And again, make sure you know how to solve consecutive integer questions. They're pretty common and they're pretty straightforward to solve once you know that they look like this, this, and so on. Okay, that was question 2. See you maybe at question 3.